Air is flowing in an insulated duct. Properties of air at two arbitrary sections are as follow. Here at section A, pressure is equal to 130 kilopascal, temperature is equal to 50 degrees centigrade, and section B, pressure is equal to 100 kilopascal and temperature is equal to 13 degrees centigrade. The direction of the flow is from, here the options are A to B, B to A, C is insufficient data, or either A or B. Here first let us assume that the flow is from A to B. So here the change in entropy from A to B is equal to the integration of from TA to TB Cp dt by T minus PA to PB R into dP by dP. So here SB minus SA is equal to Cp ln T, that is ln TB by TA minus R ln PB by PA. So the given fluid is air. So for the air, Cp is equal to 1.005 kilojoule per kg Kelvin and Tb is equal to 286 Kelvin and TA is 50 degrees centigrade, that means 323 Kelvin minus 0.287 into ln by 100 by 130. That is the pressure at the section B is equal to 100 kilopascal and pressure at the section A is equal to 130 kilopascal. It gives a value of minus 0.047 kilojoule per kg Kelvin. So this is the change in entropy of the system from A to B. But the air is flowing through a insulated duct, so that's why the change in entropy of the surroundings is equal to 0. There is no there is no change in entropy between the surroundings and the system. So the change in entropy of the surroundings is equal to 0, and the change in entropy of the universe is equal to the change in entropy of the system plus change in entropy of the surroundings. So here change in entropy of the surroundings is already 0 and change in entropy of the system is minus 0.047 kilojoule per kg Kelvin. But we know that the change in entropy of the universe is always greater than or equal to 0. It cannot be a negative value. But here we have negative value. That means what we have assumed is a wrong assumption. The assumption is the air is flowing from A to B. But we got a value of change in entropy of universe is equal to a negative value. So it is impossible. So that's why the flow is also impossible to flow from A to B. So the correct answer is the flow is from B to A. So B to A is the right answer, and in the options the correct option is B. B is the right answer. A tool with mild steel workpiece was found to give a life of 2 hours while cutting speed is 50 meter per minute. Assume Vt power of 0.27 is equal to constant. Calculate the tool life if the same tool is used at a speed 25% higher than the previous. Here the options are 40.05, 45.05, 49.05, 52.25, 52.2 in minutes. Coming to the solution, according to the here the given equation is Vt power of 0.27 is equal to constant, and first the tool gives 2 hours life while cutting speed of 50 meter per minute, that is 50 into 2 hours, just convert into minutes, whole power of 0.27 is equal to constant. So we get here a constant of 182.1. Now calculate the tool life if the same tool is used at a speed 25% higher than the previous one. So now the new velocity is 25% higher than the previous velocity, that is 50 into 1.25, which gives 62.5 into t power of 0.27 is equal to constant and is equal to 182.1, and from this equation you get t value that is equal to 52.2 minutes. So in the option the correct option is D. D is the right answer. Of the same metal have the same surface area. One casting is in the form of sphere and other is in the form of cube. What is the ratio of solidification time for a sphere to that of cube? Here the solidification time for a casting is given by K into V by A whole square, where K is the solidification constant and V is the volume of the casting mold or casting, and A is the surface area. Here the given condition is the surface area for the sphere and cube is both are same. So here the sphere area is generally 4 pi r square and surface area of the cube is equal to 6a square, where A is the side of the cube and r is the radius of the sphere. So from this relation we can get the relation between the radius of the sphere and size of the cube, that is r square by a square is equal 6 by 4 pi. So coming to the solidification time, here we will have to find out first volume of the sphere and volume of the cube, that is, let us say the ratio of solidification time to the solidification time of the sphere to solidification time of the cube is equal to the ratio of volume of the sphere to volume of the cube. Since here surface area of the both castings are same, so that Vs by Vsc is equal 4/3 pi r cube to the a cube, and here it is Vs by Vc whole square, and it is whole square and 4/3 pi whole square into r cube by a cube whole square. Here already we know that the r square by a square, the relation between the ratio of r square to a square. So from this equation 4 pi by 3 whole square is equal r square a by a square is equal 6 by 4 pi whole cube, so which is equal to nearby 6 by pi, and in the option the correct answer is B. B is the right answer. With a cross section of 150 mm by 6 mm is being rolled with 20% reduction in area using 400 mm diameter steel rolls. The angle subtended by deformation zone at the roll center is. Here the options are 0.0755 radians, 0.0125 radians, 0.092 and 0.123. So coming to the solution, here the angle subtended by the deformation zone at the roll center is given by theta is equal to square root of change in thickness, that is the final thickness or initial thickness minus final thickness to the radius of the roll. Here the cross section area of the strip is 150 mm into 6 mm, that is the initial thickness of the strip is equal to 6 mm, and it is being rolled with 20% reduction, that means the final thickness is equal to 0.8 into 6, which is equal to 4.8. So here the theta is equal to 6 minus 4.8, and the radius of rolls is given by 200 mm. So because the diameter of the rolls is equal to 400, so that radius of the rolls is equal to 200, so it gives a value of 0.0775 radians. So in the option, the correct option is A. A is the right answer, 0.0775. Here match list 1 with list and select the correct answer by using the codes given below. In the list 1, there are 4 metal forming processes, and in list 2 there are associated forces. Here coming to the process, wire drawing, extrusion, blanking and bending. So here wire drawing generally associated with the tensile force. So and coming to the extrusion associated with the compulsive force, and coming to the blanking is nothing but its shearing operation. So it is associated with shear force, and bending is associated with the spring back force, because in bending we have some spring back force due to the stiffness of the material. So here in the option, the correct option is C. Regarding all these associated force, the correct option is C, because wire drawing associated with tensile, and here Q is extrusion associated with compressive, and R is associated with shear force, and bending is associated with spring back force.